Okay, continuing along. The summary is that we found the height at which the engines fail. We cannot use the same strategy to find the maximum height from here. And that's because this equation that we used at first, we knew what the initial velocity was on the launch pad. It was 0. The initial velocity going from this stage to this stage, well, that's an input to this equation which we don't know. So to continue, well, we can also examine another equation, another kinematic equation, which says velocity final squared is equal to velocity initial squared plus 2a delta x. This one looks good. Doesn't involve a time because we don't know the time in this phase. But again, we need to know the initial velocity. So it seems as though we cannot reach the top until we also know the velocity here where the engines failed. So this is an example of a difficult problem. We have a goal in sight, but we're having to calculate intermediate terms in order to reach there. So to calculate this velocity, here we can use the kinematic equation. Final velocity is a function of your initial velocity plus acceleration through time. Here our final velocity, to translate this into our specific situation, our velocity at 2 is equal to the velocity at 1 plus the acceleration, which is upwards, 2.8 meters per second squared, delta t, which we know, in my case, it was 30 seconds. Yours might be different. Velocity at 1 is 0, so this isn't difficult to calculate. We now know how high we are and how fast we're going when the engines fail. From this point, we can reach the top. Let's use this equation here, because we don't know time through here, but we do know our final velocity and our initial velocity. Actually, someone might ask, what is that final velocity? If I translate this equation, this says velocity at the top is equal to velocity here where the engines fail, plus 2. Acceleration is negative 9.8. It's downwards. Now it's going to be slowing us down, not speeding us up going. 2a delta x, here is delta y. This is our delta y. Delta y. Do we know the velocity up here? What's the velocity of any object that reaches the top of its arc? Well, at least in the vertical direction, for a brief moment, at the very top of the arc, at the maximum height, the velocity is 0. So this equation says 0, this implies 0 is equal to v2, which we know, plus 2 negative 9.8 meters per second squared. Delta y is final minus initial, which is y3 minus y2. We know y2. So we know everything. We can solve using careful algebra. We can solve for this maximum height. So that's a lot of work just to reach the top. Find the rocket's velocity at its highest point. We already mentioned that answer to part B. The velocity of the rocket at the top is the velocity of all objects that are thrown straight up that eventually come to a halt just before they fall down. Right there, the velocity v equals the rocket's velocity at the highest point. Velocity 3 equals 0 at the highest point. Find the magnitude of the rocket's acceleration at the highest point. This is one of those questions. The question is, what's the acceleration? It's easy to say 0. I've warned people in class, and I will be asking, actually I'm going to guarantee it, I'm asking this question or something almost identical to it on the midterm and on the final. You'll hear this question 2 more times. What's the acceleration at the very top? Well, everybody sees the motion, which is velocity, is 0 for a moment, but the change in velocity is a constant. Gravity is affecting you at every moment. It's slowing you down, it eventually stops you, and it pulls you down. At every moment, there's a little change in your velocity. Through 0, here you're going from fast upwards to medium to slow to stopping. Here you go from stopping to slow, medium, fast, downwards. The whole time your velocity is changing, and a change in velocity is your acceleration. Acceleration is a constant even at the top. So, part C, the magnitude, is 9.8. Now remember, things are starting to get complicated, especially if it's a vector. So if this was expressed as a vector, well, actually, no, it's already, I won't complicate things in this. This is already complicated enough. But let's just remind ourselves that 9.8 is the magnitude. These are the units, meters per second squared, and this is the sign. The sign gives you direction information. This magnitude is the amount, and the units tell you what you're talking about. All right, I think I'll stop this video here.